Hi, today lesson we're going to focus on multiply radical expression. Okay. For any real numbers, n root of a and n root of b, where n is greater or equal to 2, then the n root of a times b is equal to the n root of a times the n root of b. And it also works the other way around too, right? So if you have n root of a times n root of b, you can bring it under one root, which is n root of a times b. Okay, a little note here, when you multiply two radicals together, those radicals have to have the same index. Okay, so what do I mean by index? So let me explain, go through some notation here before I jump to the example. So if I have n root of a, here n, this little n here, that's the index. That's the index. Okay, and a is called the radicand. The radicand. All right. So so when you multiply two radicals together, they must have the same index in order to bring them under one root. Okay. All right. So okay. Examples: multiply the following radical expression. Assume all variables are positive. I have square root of 11 times quantity of a plus 4 times square root of 11. So all I have to do is distribute the square root of 11 into the parentheses, right? So equal square root of 11 times 8 plus square root of 11 times 4 square root of 11. All right, just write out the basics step. Okay, you don't have to do it all at once in your head. Chance that you're gonna make a mistake if you do so. Okay, so square root of 11 and 8, they don't have the same index, so nothing I can do about that, right? So just rewrite it as 8 square root of 11. I like to write it that way. Plus, so I can bring the 4 to the front, right? A times b is equal to b times a. The commutative. Square root of 11 times square root of 11. Here we have the same index, right? They both square root. I know that we don't write it out. We don't usually, when we say square root, we don't write the 2 in, but is understood as square root of 11 times square root of 11, same index. I mean, this is equal to square root of 11 times square root times 11, right? Which is equal to what? Which is equal to square root of 11 square, right? Square and the square root cancel, so that's just equal to 11, right? And 4 times 11 is 44, right? So I have 8 square root of 11 plus 44. Okay, example number 2, I have quantity of 8 minus root 2 times quantity of 3 plus root 2. Now, when I say root 2, I mean square root of 2. Okay, so here in this case, we're going to FOIL them out. Okay, so FOIL, first term, 8 times 3 is 24. The outer term, 8 times square root of 2 is 8 square root of 2. So positive 8 square root of 2. Inner term, negative root 2 times 3 is negative 3 root 2. And last, negative root 2 times root 2 is negative root 4, which is 2, right? Which is 2. Here is minus 2. 24 minus 2 is 22. Now, 8 root 2 minus 3 root 2, these are like term. These are like term. Okay, so what is considered a like term in radical? So if they have the same index and have the same radicand, remember here up here, what is the index? What is a radicand, right? So here they both square root, right? They both have the index is 2 here, right? 2 here, and the radicand is table 2, right? Here's the radicand is this guy right here. Maybe I'll underline in purple. Same index, same radicand. We can add them together, right? When we add them together, we only add the coefficient in front of those, the root, right? So a minus 3 is 5. So it'll be positive 5 root 2. Okay? Think of them like x. So for example, you have ax minus 3x is equal to 5x. Okay. All right. Okay, and that will be our final answer for number 2. Problem 3, oops, I've missed a parenthesis here. Same thing, right? Same thing. We're gonna FOIL it. When we have 2 binomial, we FOIL them. First, 7 times 7 is 49. 7 times negative root 10 is negative 7 root 10. And in the term, root 10 times 7 is positive 7 root 10. And then last, root 10 times negative root 10 is minus root 100, which is, maybe I'll write out root 100, right? Equal, the square root of 100 is 10, right? So 49 minus 10 is 39. And the middle term, they are like term, however, they have the same coefficient in front of the root 10. It's just opposite sides, so they cancel. So these guys are canceled. Negative 7 root 10 and positive 7 root 10 cancel. Okay, so our answer is 39. Okay, by the way, 7 plus root 10 and is the conjugate of 7 minus root 10. Okay, so what is a conjugate? Conjugate is something like this. I have a plus b. The conjugate of a plus b, usually conjugate, they put a little bar in front of the expression is conjugate. So this implies, so what's the conjugate of a plus b? Is simply a minus b. Okay, so conjugate is basically when the sign between 2 terms are changing. Okay, so 7 plus root 10, the conjugate of 7 plus root 10 is 7 minus root 10. Okay. All right, the last one is involving variables, but we have to do the same thing, right? So I have square root of 27 x to the 5th times square root of 108 times x to the 3rd. Now, before you actually bring them under one root, because you say, hey, Mimi, they have the same index, right? All I have to do is to bring them under one root, right? But before we do that, I think it's best if we can simplify each of these term first before we multiply them together, right? So let's see what I can do. Square root of 27, I can write it as square root of 9 times square root of 3, right? And then square root of 108 is the same thing as square root of 36 times square root of 3, right? And then I'm going to multiply the variable together. I have x to the 5th times x to the 3rd. Okay, all right, let's simplify them. Square root of 9 is 3. Square root of 36 is 6. Root 3 times root 3 is root 9, which is 3. And then for the variable, square of x to the 5th times square of x to the 3rd, same base. All you have to do is you add the exponents, right? So we square root of x to the 8. 3 times 6 times 3, which is 54, right? Square root of x to the 8 is, if you want to, so this is radicand expression, right? So if I want to change it into rational expression, I can write it as x to the 8 over 2, which is x to the 4, right? So this is x to the 4. So that's how we multiply radical expressions. Thank you for watching.